Okay, well, thanks for being here. You could have been in any different session and you choose to be here. Proves 2 points. One, you love Postgres. Two, you love coffee. So we'll get started. My name is Varun Dhawan, and I'm a principal product manager with Azure Database for Postgres team. We are known for creating awesome managed service, which is Azure Database for Postgres Flexible Server. And then we are also known for creating awesome socks. How many of you have collected socks? Okay, cool. We have more socks after this session, so be around. I'm still getting adjusted to the stage to decide whether I look here or I look here. So probably I should be looking here. Okay, so this is something about me. I'm a principal PM with Azure Postgres team. Again, when you think about Microsoft, most of you think about SQL Server or what else? Sorry? Azure Data Factory. What database do you think about? Cosmos, maybe? But we do significant work with open source databases, and especially a lot of investment goes into Postgres, a lot of investment goes into MySQL. Today we are out here in full strength, to show what do we do with Postgres. I have 20 years of experience working on relational databases. I am not an accidental DBA. It was actually intentional. I was working on something else. I was preparing for my CA. And then I came across a session where somebody was explaining about Oracle ERP, Oracle Financials. And this is about 2002, so I'm dating myself a little bit over here. How many of you, think about ERPs, So when I was first taught about ERPs, the first thing that came to my mind is where do and how do they store this information? So obviously it was a database, and I got excited, and since then I've been working on databases. So I've worked prior to Microsoft, I've worked at Target, and then I've also worked as a DBA at McKinsey, doing late night on-calls. Right now, I'm based in Minnesota. It's a beautiful land of 10,000 lakes. And besides Postgres, besides coffee, one thing I really, really love is blogging. I do blog a lot. Right now, I mostly blog for Azure Database for Postgres, which is our managed service, but I do have a personal blog, which is Data Nerd. And I think I printed a sticker for it, You can find me on social, my LinkedIn, all the social handles. Okay, so this was the coffee I had today in the morning. I think this is a filter coffee, and again, I spent 10 years in Bangalore, so every time I come to Bangalore, this is among many other things which are best about Bangalore, this is the filter coffee, right? So which means I already have a very tough competitor. I would say, if this is the best coffee, what are we going to find, Well, we'll still try to find something better nearby. Okay, so how many of you remember, who is her? Dora? Okay, what has Dora in common on this screen? Dora uses something. Whenever she goes for an expedition, she always uses something. She uses a map. So we are using a Dora map, just to make it very simple. And this is exactly what we are going to cover. So we are going to say that for finding the best coffee from Postgres, obviously we need to have a data set, cafe data set, or a coffee data set. And we learn that until now, for many decades, we've been doing a pattern matching search and a full text search to find things, in this particular case, find coffee. But as you go further in the map, you will also talk about the new capabilities, which is the vector capabilities, semantic search, re-ranking search, and then retrieval augmented generation. So the modern techniques of finding things within your database. Again, in this particular context, the database being Postgres, but it can be any database. So first of all, are we good with this? Everybody by show of hands, everybody understands the map. We'll follow the map along. What does Dora do when she has to use a map? She has a magic word, right? She says map 3 times, and then the map pops up from her backpack. Okay, so that's the story premise. Where we are? What's this place? Yeah, pretty much the place where we are sitting right now. So that's the story premise. So after a full day of very insightful sessions at PGConf India, you're ready to unwind. I believe everybody is. You and your fellow attendees are looking for a coffee spot nearby to relax and chat, but you are in a mood of cozy vibes, tasty snacks, and a great ambience. Sounds good? Like, sounds fun. The key thing is, obviously, Bangalore has traffic, so you don't want to go too far. You want to be somewhere nearby, so it should be within 5 kilometers. Also, be considerate. Some of you may have parked, your cars in the hotel, so you want to go, drink coffee, have some fun, and then come back. So all those parameters. Now, how can Postgres help? Now, with Postgres' robust geospatial and vector capabilities combined with RAG, retrieval augmented generation, we can find the best coffee spot nearby. So we will walk through the journey of turning the basic text into the context-aware searches. Now, context-aware searches is that when you do search on your database, you're just not searching for things which exist in the database. You're searching for things that exist in the database along with the meaning they hold, along with the context they hold. So we are going to do that context-aware search or learn how to do it. But we'll follow the map. Okay, so the first step in the map is cafe dataset. Obviously, we are in the Bangalore. What is the most famous online delivery service in India? Zomato. Like, I think it's cat versus dog, Zomato versus Swiggy. How many of you have better experience with Zomato? And how many of you better experience with Swiggy? Okay, well, it's a divided thing. Okay, well, I chose Zomato. So here we are. So what I've done is Zomato has a pretty big data set. They have published an open data set. I have taken a data set of Zomato only for Bangalore specific region, where I've got 8,000 businesses and 50,000 reviews. Now, actually, it's a little incorrect when I say Bangalore. Bangalore is pretty big metro, and I've lived in Bangalore for 10 years, and we Bangaloreans love to eat, so it's like 8,000 businesses does not make sense. So 8,000 businesses are only within this vicinity of Rajaji Nagar, right? So I've taken all these businesses, and I have all these reviews. And this data set exists like this. So if you go to Kaggle, where this data set is published, and for anybody to download and use, this is how the data set exists. Some of the things are usual suspects, like, okay, well, what's the restaurant name, what's the address, whether they take online order, rating, etc. But we are looking in for data from where we can derive context. Now, what is the data where we can derive context from? What type of data? Can anybody think about kind of data which gives us more context and more meaning? Sorry? Sorry, I couldn't hear. Reviews, maybe, like people write reviews, they tell, then what exactly is the menu, those things. So when you see a lot of large chunks of text, that's where you can go and read and ingest that text, and then you can start making sense of, that particular text. So we take all that data, built inside our database, ingest into it. So I will leave with the boring part, that I've taken this data, this is a JSON, I've used some function to get the JSON ingested inside, Postgres, blah, blah. I think you are all smart enough to do that part. So now that the data already exists in our database, let's see, what do we do today with an I-like kind of a search. So I-like search using Postgres is used for pattern matching. So you can do search on a text where something like restaurant or something like cafe, and it's basically good, like we've been using this kind of a search for years and years, and you can write very, very, very sophisticated query, and then someone was telling me that you can make it like contains or exist or similar, so there are many different variations of doing pattern matching search. So very powerful. So if I do a basic search over here on my table, and this is like my table, which is Zomato, data, and I'm searching for restaurant type which has casual vibe or, serving something like a coffee, I do get a lot of things, over here. Like, can somebody, by the way, see these restaurants? Like, these are actually nearby. This is the real data. Pretty good. However, when I search for something like, okay, this clicker works. No, okay. But when I search for something like coffee with a sandwich, this does not show us anything. Why? Someone? Because that string does not exist. It's coffee with sandwich. That does not exist. It may be coffee and a sandwich and something else, but coffee with a sandwich does not exist, and you do not see that data, right? So, okay, this is a video. I've explained this, so I'll skip this. So pattern matching search is simple, but has its own limitation when it comes to complex phrases and contextual searches. So when you do searches like cafe with chill vibes, you pretty much get nothing. So then we'll move on to the next phase of the DORA map, where we can try using a full text search. Now, full text search came after pattern matching search. It's a little more sophisticated. Again, has existed for many years. Do we need any extension for full text, using full text in Postgres? Yes or no? Yes or no? Actually, no. Full text bakes in, like you just don't need to install any external extension. It's just available. There is a data type called TS vector. I'll just show you. So full text, we use, again, it uses very powerful text capabilities. Full text works with a dictionary-based search, and I'm going to show you how exactly it works. But using a full text, if you search, and I'm going to show you in a minute, you search for restaurant, and you see how I'm passing English as a query input or a function input, is because I'll say that use what kind of dictionary to do these kind of matches, dictionary matches. So it shows some data. We'll see it in the demo. So this is a full text search. Let's start from the top. So what I do is I just add a new column, TS vector. It's a derived column, does not exist. And then I populate the column. I convert and I populate this column. I took up the menu items and create a full text column on top of it, which follows the English dictionary. So pretty straightforward. Now, whenever I create a column for a specific data type, what do? I always create, or we always create what? We create an index, because we want queries to run faster, more precise. So I've created an index, GIN, generalized inverted index. I may be wrong with the definition, which I believe is the best for full text data. So if you see, I've done all that, and then run a sample query over here, I get a last column, which is menu item search. Now, what exactly it's doing over here? So it's taking individual words in the menu. It's reading to the text, English text. It's doing away with all the punctuation. So it's throwing all the and, the, or, all those things. So it's just taking the main words. And then within a sentence, it's taking how many times the word is repeated. So it's storing the position, and it's also storing how many times the word has been repeated. So the word starts having a weight, And then based upon that, when you do a full text search, it can give you an output. So we'll see in the next slide. So in this particular case, I'm doing a full text search, which is web search to query. I think there are phrase search, and this is more sophisticated, a web search to query. And then I pass the same thing, in the where clause. It's like web search to query English, and I want coffee, and I actually get a lot of output. Are these good output? Are these bad outputs? Good enough, right? We're searching for coffee. It's giving us reasonable things. However, what do you think if I do coffee with sandwich? Will it give any data? Will give or not give? Why will it not give? It will not be able to understand the context. It's still not context aware. It's still trying to use the text or the strings that exist inside the database, but it's not able to understand the meaning or the context behind those things. So if I run this query, coffee with a sandwich, I get 0 rows. Okay, well, so far we are still starving to have coffee. We haven't got. This is the video. I'll skip it. So full text is better for phrase-based searches, but struggle with nuanced searches like cafe with chill vibes, or it doesn't get a lot of data. So now we're going and we'll start discussing about the fancier way of searching things, which is using the AI-based searches or semantic searches, whatever you will call. Now, semantic searches, and you've heard this, this probably might be the most overused term besides Postgres. The other most overused term in this conference might be the vectors. You may have heard so much about it. So I'm going to put some fun twists to explain you some foundational elements. Correct me if I'm wrong if those foundational elements are not really right, because vector is a mathematical concept. And I'll be honest, I was super bad in my maths in my high school. So I may have got few things mixed up, but let's understand what are the vectors. So vectors are the numbers that represent the items in higher dimensional space. So for example, if you just take something simple like a string, like a dog, it might represent something like 070805. It's just a number, like bunch of number. And then if you take a cat, it will have something very similar. And if you were able to plot it in a very simple two-dimensional graph like this or a three-dimensional graph like this is how it looks like. Each number in a vector is a dimension in space. So generating vectors is very important because that becomes the first or the foundational step for doing any kind of a contextual search. So now there have been many models, if you were to call them, that help us converting the text or string text to a vector. So one of this model has been an older model, which is word2vec. And if you feed in a dog over there, you get this some kind of a vector output or a number output. If you feed in a cat, it gets a different output. Besides the fact that dogs are better than cat, I think these numbers are just numbers. Everybody agree? Dogs are better than cat? I normally get, okay, it's clear. Now, you can feed this data into many models. So Word2Vec has been there for very long. But now, thanks to the ChatGPT movement that happened in 2022, now we have so many more sophisticated models, which we normally call them as a large language model. So the large language model, the capability is quadrupled, or more, where now you can have more dimensions. So if you feed the same dog and the same cat, now it has more dimensions and more things to look for. So let's see basically what happens over here. So in this particular case, I'm just doing a basic comparison. So if you feed the word dog over here, on your left-hand side is a Word2Vec model. On your right-hand side is an OpenAI model. I think this is a little old, so this might be OpenAI 3.5 or 4. But if you feed the dog, you get a lot of similarities. So dog on a Word2Vec is more similar to cat, horse, child. And then it is least similar to some very weird thing. Like dog is very least similar to Switzerland. I don't know why. Maybe they don't have dogs in Switzerland. If you look on the right-hand side with the OpenAI model, which is 1536 dimension, very interestingly, OpenAI thinks the dog is very similar to God. But at the same time, there are many other synonyms and many other things where it is least similar. So this is one way of very, very simple explanation of understanding that when everybody keeps talking about the vectors, this is how basically the vectors are generated. Again, one of my colleagues at Microsoft, Pamela Fox, she's awesome. You should see some of her work on YouTube. But she has created this vector comparison tool, which I'm using over here. So it's free. Click a picture, use it right now on your phone, search for dog, search for anything, and then you can do a basic compare. So why do we care about vector embedding? Like, we cared about vector embedding for two different reasons. We care about similarity because we want to find the similar items in a very large data set for making a useful recommendations. And second, we care about search, because we want to search other items that are similar to what you are querying. So similarity and search, these are the two reasons, we care about vectors a lot. Maybe at this time, I'm going to do a little risk and show you a little tool. I shouldn't be doing, this deviating from the original, but this is a TensorFlow project. You can use it right now, project.tensorflow.org. And if you pass any word, okay, let's try cat. You can see the things, the words, actually, hold on. Whoa. Okay, well, it's somehow not liking the word cat, obvious reasons, so let's stick with dog. So if you see the dogs and click on dog over here, it shows what I was showing in my PPT, the things which dog is very similar. And then you can also see what are other similar objects like dog. So you can this is like a very, very basic way of understanding how vectors exist in a vector space, Okay, back to our PPT. Please, please, please. Okay. So again, I just showed you the Google TensorFlow project. You can find and you can use it. Now, all this thing, I understand vector, I understand how the vectors get stored. So if, coming back to the Postgres and relating it with what we are trying to do, if we somehow take all the restaurants and take all the menus and convert all the menu items into vector, this is exactly how they are going to look like. So I have a restaurant, and then I have a menu column, and then I have the menu description, which I have vectorized, and then I have the huge amount of text over here. So this is how basically the vectors get stored in a Postgres table. So now that we are back from our detour, that we have understood vectors, we'll see how we can use these vectors and do some sort of a semantic search. And still, what are we looking, by the way? I think we are getting a little lost. We are there for, look for coffee. So we still want to find coffee. So we'll do some fun searches around coffee. So now that, let's dive into semantic search using vector data. So using OpenAI embedding and Postgres vector capabilities, we can search reviews like natural language, which is like cafe with chill vibes, you know. So I have, like, I think in some of the slides, I'm going to show you how I construct this particular query. So let's park this for now and maybe see the demo a little bit. Let's understand. So we need some tools in our arsenal to make sure that we can run, we can run all the semantic search. These are new goodness things. So for Postgres, it's very easy. For most of the things, we get extensions. So I'm using a bunch of extensions over here for my demo. So I'm using Azure AI extension, which allows me to integrate AI capabilities into Postgres, so I can create embeddings and I can do searches. I'm using Postgres extension. Why am I using Postgres extension here? Because we are here and we want to coffee find nearby. So we have to use geospatial capabilities. Obviously, we are using vector extension because we are storing the data in vector. And I'm using a very interesting extension, which is PGDisKNN. You may have heard about in some of the sessions, but I'm going to explain this is the new type of a vector index that came from Microsoft Research. So 4 extensions. Whoa, am I going a little fast? Okay, so I think I've kind of compiled it into a few simple steps. So what I've done is I've created an empty vector column, okay, with a vector data type. And then in this particular step, it's basically a declare loop. All I'm doing is that I'm taking all the rows inside the database, and with this new column, I'm creating the vector embeddings. Now I'm taking how many columns? I'm taking 3 columns. I'm taking the restaurant name, the menu item, and the cuisines. And I'm combining all these 3 and generating this huge set of vector. So that when I do my searches, I get all the 3 things into my recommendations. So if you start reading on the top, test, like basically my vector data already exists. Now, just like the full text search where I created the full text column, and the next thing I did was created an index. Over here, I just created a vector column. So what should I be doing next immediately? I should be creating an index, right? Now, can someone explain that the way indexing work on a regular data type, maybe including the full text data type, versus the way indexing work in vector data type, is it same or it's slightly different? So what do index basically do for the data? They make your queries run faster, right? But indexing on a vector data type has another purpose, which is for the accuracy, which is like how accurate I'm giving the results. So if you visualize that map which I was showing you, dog, and there's something which is very close to the dog, and the cow was very far away from the dog, if you're using the right index, then actually cow will remain far away from the dog, and cat will remain close because maybe they are house pets, something like that, and a lion will be very far because lion is a wild animal. But if you're not using the right index, you might get results which are a little more jumbled up. So in this particular case, we're using a PGDisKNN index. If you were not using a DisKNN index, what vector index will you be using, which is available for everyone? IVF flat and HNSW. So it's totally good to use. And then when I've created an index, I'm just doing a basic search, Now I'm doing a search using the order by, and I'm not using the where clause. Like we use, where clause is meant for searches. Why are we using order by? What problem do we solve with where versus what problem do we solve with order by? we get the nearest neighbor with the order by. So with where, we go and we pinpoint and find, like, out of billion rows, give me exact thing which I'm looking. But with a vector search and with an order by clause, we say, give me things in the order of how similar they are to the thing that I'm looking. So this is why I'm using an order by search with a cosine operator, and I'm using a text embedding small model. Now, you might have not noticed, and somebody asked me this question earlier. It's an awesome question. When you create vectors, you use a particular type of embedding or a model, and when you search vector, you have to use the same model. If you use two different models, you will not get the output. Okay, so little detour into disk-KNN. So disk-KNN is like highly performant, scalable, and accurate index for vector. They are superior to IVF flat and HNSW, something that not I'm saying, but based upon all the research which is published. Primarily, it has the reduced memory footprint by storing the vectors on SSD. And when we say storing vectors on SSD, it stores the intermediate nodes of the indexes on the SSD. And then it uses compression and quantization techniques for the improved speed and accuracy. And accuracy is retained as the data is changed because, well, it's a live system. You keep adding more restaurants and more reviews, and it automatically gets indexed. So there's a whole blog about PG disk-KNN, which you can read. I've linked it in the end. So coming back, with our search, so far over here, I ran a simple query. Now we are actually getting, like, I got a couple of restaurants, cafe, coffee day, cake port. Has anybody searched? Know these restaurants are there nearby? Anybody gone? Like what you see on the screen? Okay, I believe they exist because it's coming from the Zomato data set, so it's good enough, But is it telling me that which restaurant is nearby? Not yet, because we haven't married them to the geospatial data yet. So let's start with the geospatial journey. So for geospatial, we need PostGIS extension. I've already told that yes, we already have PostGIS extension. So I'm adding another empty column, which is restaurant location, which is geometry data type, and then I'm updating the column where I can store the latitude and longitude with a point precision. So okay, see the second column, the point of every restaurant. So now basically if you can take this and maybe you even use a mapping service or a mapping API, you should be able to still find where is this Coastal Spice restaurant. Like, I'm very curious, has anybody gone any of these restaurants? If you find that, oh yeah, I have gone in one of these restaurants, that will be the win from the session. Okay, so we now have two very interesting columns, the restaurant location and description vector. What are we going to do next? We are going to write a query which will be a hybrid query, which will combine a geospatial data and combine our vector data, and we get the best of both the worlds. So this is now my hybrid query, which is like very big query. It's fine. If you can, just pay attention, to the highlighted part. So you see the spatial filter over there. So all the green part is where I'm doing a filtering of this spatial. Can anybody tell what is the significance on line which says 0.775536130110? This is the geospatial location of Sheraton. And then 5,000 over there is the radius, 5 kilometer radius in the Sheraton. And then the pink part is our usual vector search or the semantic search, where again I'm using a cosine operator with a text embedding, and I'm passing my favorite phrase, which is coffee near me with sandwich. So it's now the key part is I'm not saying, I'm not specifying where am I. I'm just saying coffee near me. It will understand the whole thing because I'm giving the point location over there. And I'm getting, again, very, very precise results in the bottom. So OG, Virar and Sons, Stories, Eat Fit, and Barbecue Nation. I bet you guys have been to Barbecue Nation. Come on. Okay. So, okay, is this good enough? Should we stop over here? We can say that this is the coffee places, or we can improve this. Who believes we can improve this? We can improve. We can improve it using what? RAG? Okay. So let's use the RAG technique, So again, this is a video, but I'm showing the real thing, so I'll skip this. So now we are at the step 5. We've done the semantic search. We find a lot of coffee places. I think these places are nearby within 5 kilometer radius, but I still need more precise answer, as if I'm just Googling and getting an output in first page, like, because reality is nobody reads second page of Google, nobody. So I just need first few answers, and I need it from my application, I need it from my database. So we will build a RAG application over here. Now, let's understand what is RAG. RAG is retrieval augmented generation. It's the process of retrieving relevant contextual information out of vectorized data set and pass that information into LLM to generate answers. So far we are creating embeddings, and then we are searching for the embeddings, and we are getting an answer. But imagine if you get 100 answers, if you get 100 restaurants or 20 restaurants, let's say 20 is a reasonable thing. So if you get 20 restaurants and again pass it on to LLM, GPT, Gemini, Hugging Face, whatever you use, and then say, hey, hold on, I know you've been trained on the entire internet knowledge, but for this specific search, just take these 20 restaurants and then just tell me exactly what I want. I'm really tired, I want to go. We are 4 friends, one of my friends is strictly vegetarian, the other 3 are non-vegetarian, we want to come back on time, there has to be a car parking, each of us have decided we are not going to spend more than 500 rupees. All the parameters, and then you can pass and just make sure, give me those answers, based upon this data. Well, we so far cannot get that data, from the data set. So if you were to do this, this is how exactly it looks like. So instead of directly asking LLM a question and hoping the answer lies somewhere in the training data, the data it learned from internet, we provide the context source from our vectorized data set, which is the 20 restaurants that we have already figured out, and then reference it with the context searches to get more precise answers. So this is basically the flow of the data. So user searches for coffee, it goes into Azure OpenAI embedding, embeddings are stored inside database, which happens to be Azure Postgres in this case, you get relevant coffee results. However, at step 3, you do not consume the results from there, but you feed the results back into an LLM and get more better recommendations from there. Simple? Okay, so now I'm going to do a demo. This is a real demo, so pray to demo gods. Hope everything is working. So I've created a Python app. Let's talk with the app. So that's my Python app. Is everybody able to see? Okay, it's a very simple app. I'm not a Python developer. I'm still a DBA, a bare-bone app. So let's play around. So I'm going to give an Azure endpoint, and I'm going to give an API key. Hope it's right. And the model, GPT 4.0. Connect. Okay, so far so good. And what I've done is these 20 results which I keep talking over here, 20 or 30, I have stored them inside a JSON file, And to this RAG application, I'm going to feed that JSON file. So this is my initial context result with a coffee near me with sandwich. So I'm going to feed this over here. This takes a minute. So far, so good. So I have 20 results which are 20, or I don't know, probably they are more, maybe 20, 26. So all of them, are fed into over here. Now I'm going to start talking to my data. So I'm going to say, my first prompt could be coffee near me. It's running on top. And it says, okay, it gives me 3 outputs. Now you have to keep me honest over here to make sure that Zomato is just not faking the data. So there are 3 restaurants, South Italy's, Frozen Hit, and some biryani. Are these real? Is real? Okay, well, half win. But let's make it interesting. Coffee near me with sandwich. I won't go far with the gluten-free, so just the sandwich. Okay, so now my second prompt has a very different, so it still says Frozen Hit and South Italy's, but it also says break hour, and then it's giving me some very interesting recommendation, and maybe I should be kind of doing this a little. So from the document, Frozen Hit and break hour appears to be the best option for coffee and sandwich. Now I need a little bit of a crowd help over here. I want to make this prompt very interesting. What else can I add, Something about distance. So can I say that within 10 minutes walk? Reasonable? Okay, running. And it says based upon the data provided, and you need 10-minute walk, These are the options. All three locations are within 10-minute walking distance based upon their geolocation coordinate. What else? How can I make this prompt more interesting? Who else wants some live music? I don't know. It says based upon the data provided for the live music and walking destination, uh, I think it's returning the same restaurant, but it's not very sure about live music or no specific information of the live music or walking distance. Anything else you typically want, like if you really were going with your friends hanging out after this conference, what else will you add? Give me one or two things. Sorry? One at a time. Buy one, get one. Oh man, you can't beat that. Like, oh, there you go. Like with, buy. I think you are basically trying to imply happy hour. So maybe I should say, and happy hour. I love the prompt. Okay, so based upon the provided document, the following places might serve coffee with a sandwich in your vicinity. However, none of them explicitly mention a happy hour, promotion, or walking distance. Yeah, like, I bet there are happy hour, it's not there in the document. Sorry? Takeaway, okay, and takeaway option. I bet, and has take away, it's one word, right? Running. Well, this time the results actually got changed. So based upon the information provided, Frozenite offered coffee and sandwiches this within 10 minutes walking distance. And, oh, okay, well, it says you need to verify if they provide takeaway options. But if this keeps showing up, what I'm going to do is actually go type this restaurant, Frozenite. Is this a restaurant or a? Can I actually find this, or? I think this is one of the cloud kitchen kind of a restaurant. What else? Any other prompt? Okay, I think, yeah, so that gives you an idea of what I was trying to show. Let's come back. Now, for the reasons, that Zomato dataset, we couldn't get the legal clearance that we can build an app and show it to you. And I was literally working until 2 a.m. in the night. If you want to play with an app like this, you should take a picture of this right now. And if you go right now over here, PG Disk KNN demo, we have another similar dataset, which is Airbnb dataset, which is based on the Seattle location. And you can actually, on your phone, tablet, or mobile screen, you can start playing over here. The cool thing is you can see on the top that we have a no index option and we have a disk KNN index option. And then you can actually, compare the accuracy and you can actually compare the speed, So very similar. So over here I'm finding copy. In this particular demo, I'm finding the Airbnb rentals. So what did we achieve? Well, we started from a basic pattern matching search and worked our way up to the powerful RAG application using structured data. Each step built on the limitation of the previous one, resulting in more refined and context-aware application. This demonstrates the flexibility and power of Postgres paired with the advanced extension. So if you visualize it with a pyramid, we started with the foundational base of pattern matching, then full text, semantic, and then RAG stands on top. By the way, as I say that RAG stands on top, if you have attended some of the trainings, especially from Microsoft, where I also demonstrated that now RAG is also evolved into semantic re-ranker and graph RAG, so we can even better those search results. A little pitch, again, I come from Azure Database for Postgres team. Azure Database for Postgres is the managed service offering. It has all the goodness, like it's 100% open source Postgres with all the backup, security, compliance, scale out, availability, everything which you can think out. And then especially a lot of our investment recently is going into the AI. And vectors are very important for AI apps because you have the deep, you have the raw data which goes into all these learning models. And then finally, you can build nice applications on top of, like, you saw a very basic application which I built, like an elementary school application, which was a question answering application. But if you follow the same philosophy, same logic, and same kind of a thinking, you can build any of these applications. The point is that you no longer have to search the data. You can start talking to the data. This is another slide where you should be taking the screenshot, because we have actually published the entire sample application as a solution accelerator. You just run the solution accelerator, and then it will run all the resources on Azure, and then you can run and test any kind of data. I think in this particular case, it's a US case legal data set, but you can actually play around with these capabilities, absolutely zero cost, absolutely none to you. So this is available, yeah. Finally, a pitch over here. A lot of us think, okay, well, I went to the conference, and then you back on the Monday, and you think, okay, well, it was fun. We saw how to launch spaceships to Mars, all those things, but here I am back doing my regular work. Reality is, the AI is no longer the future. It's already here. Who knows, when you are actually using Zomato right now, it might be actually using some sort of an AI to find, like, okay, well, I know 3 days you've been out, so let me give you a prompt of what exactly is your favorite dish that you want to eat. So people are using AI, so it's a good time for you to learn AI. There are talks by other team members from Microsoft. Our whole full team is here. If you have questions for me, for this session, please me outside. And don't leave the socks, right? Please, I think we are running out, but make sure you come to the booth and grab an awesome pair of socks. Thank you so much. If any one of you is able to find a coffee with some of the results that were there, and you are able to decide to go over there, I'd love to join you in the evening. Well, thank you so much. I appreciate it. Thank you.